In this video, I wanted to get you guys ready for the Chapter 5 exams. We'll go through a few problems from the Chapter 5 review assignment. But before we do that, I did want to show you, just remind you what you will have available to you at the testing center that's just on the formula sheet. So here's the formula sheet that you'll get from the testing center. And take a look at what's on it. So first of all, you've got your formula for both consumer surplus and producer surplus. And it uses QP a whole bunch. Remember, Q represents the quantity of products that you're going to produce or sell at your equilibrium point. And this is all explained kind of right here. And then P represents the corresponding price for that specific equilibrium point. Okay, D of x, S of x are your different functions, and those are your two equations. For 5.2, accumulated future value of continuous income stream, it gives you the integral formula for both of them. But remember, just like your homework, these continuous income streams are always going to be constant, just to help make things a little bit easier for you. And so here's your formulas if those values are constant. You'll notice with these formulas, it still has the R of t. You technically don't need that there because R is constant. It doesn't depend on t at all. Okay, but there's your future value formula, right? This one's your future value formula. This one's your present value formula. Okay. You'll notice, though, there's still some questions on the homework, and you'll see, I think there's one question on the review that doesn't actually deal with accumulated future value. It doesn't deal with a continuous income stream at all. This formula sheet still has those formulas on there as well. These are your formulas if there is no continuous income stream. Okay, future value is here on the left. Present value is here on the right. Remember, you can model present value just using a decay function with a negative exponent. Here we talked about this in 5.3. If you let that continuous income stream go on perpetually, you've got your formula right here. I don't know why they switch it to P instead of R, but P is that same thing where it's just your income stream. What are you putting in every year? Okay, and then for my statistics section, it's got the formula for expected value, right, where you just do x times the function over your whole interval a to b. It's got the formula for e of x squared. Remember, that's important for your variance formula, which is right here. It's e of x squared minus your mean squared. Okay, so there's your variance formula, and then, of course, standard deviation is the square root of that variance. Okay, and then here's your z-score formula. So those are the formulas that are going to be available to you when you actually go and take the test. So now let's actually get into some. Okay, numbers 1 through 3 all come from 5.1. They're talking about consumer and producer surplus. And just like the homework, all three of these problems look exactly the same. All they do is they just change your demand equation and your supply equation. But they all ask the same three things. First, what's your equilibrium point? Second, find your consumer surplus. And third, find your producer surplus. How do I go about doing this? Step number 1. Set your consumer demand equation equal to your supplier demand equation. Okay, so if I were looking at question number 1, I think my problem is like x minus 7 squared equal x squared plus 4x plus 31. Depending on what your problem is, this could be relatively simple. This could be relatively complicated. This one, the way you go about this one is if you're stuck. Careful. I can't distribute that square because of the subtraction. Go ahead and just FOIL that term, that x minus 7 squared out. If I do x minus 7 times x minus 7, I get x squared minus 14x plus 49. And then you can go ahead and solve for x. Because you'll notice that if I subtract x squared on both sides, both of those x squared terms cancel out. And this becomes a much simpler equation to solve for. Okay. Once you find that equilibrium point, it's going to be an x value, right? You'll eventually solve for your equilibrium point. I think in my problem, you get x equals 1. Okay. Does this represent quantity or price? If you remember X represents quantity, so this becomes your capital Q. It's the quantity at that in order to maximize this market or optimize this market. Okay. How do you get your corresponding price? Plug it into your function. You might wonder, well, which function? It actually doesn't matter, because if you plug it into either one, if I plug it into the demand equation, or, sorry, I put D of S. That's supposed to be D of 1. So if I plug 1 into my demand equation, or if I plug it in the supply equation, you're going to get the same thing. And not just for question 1. That's for any of these type of problems. You're going to get the same thing. And so that gives you your equilibrium point. If you set the price at $36, you'll sell one product. And that's what we want. So once you have that, then you move on to your consumer and producer surplus, which of course you have formulas for. So just consumer surplus is this 0 to Q of your consumer demand equation minus price times quantity. So what does that look like in terms of our function? I would do the integral from 0 to, remember, Q is the X value. So 0 to 1 of my demand function, which is X minus 7 squared. Although it's going to be, I already foiled that out, it's going to be easier to find the antiderivative if I just leave it like that. Dx minus P times Q, my price is 36, and my quantity is 1. Remember that P times Q, you're taking that directly from your equilibrium point. Okay. And guess what? When you do your producer surplus, that P times Q part at the very beginning, you're using the exact same P and the exact same Q. So you get 36 times 1. Your integral is just going to look a little bit different because you're using the other equation. X squared plus 4x plus 31. Then you just finish solving for those. Okay, 4 through 7 are all related to 5.2. They all deal with present value or future value, but 3 of them deal with a continuous income stream. So of course you're going to be using that R over K times e to the kt minus 1 if it's future value, or your other formula if it's present value, which it should be very clear in the problem which one's which. Number 4 is future value. You're finding the accumulated future value. 5, you're finding the accumulated present value. 6, take a look at 6. If you look at 6 doesn't involve a continuous income stream. So that's not actually accumulated present value. For number 6, you're just using this formula. And depending on what it's asking for is where you're going to plug in the value that it gives you. And then 7 is a mix of both of them. It gives you the future value, it gives you a rate and a time, and it wants you to find the present value. Well, you can solve in number 7, you can solve for part A using that present value formula, right? If I want to find my initial value, I can do the future value times e to the negative RT, where R is your interest rate and T is the amount of time. So for my problem, my future value is 230,000 E, and my rate is 5.3%, so 0.053. But I'm going to do this negative because I'm starting with my future value, and the amount of time is 25. And that'll give me my present value. But then in part B, you're actually solving for that continuous income stream. So you're solving for R. And once again, you're assuming it's constant. I know I'm going through these pretty fast. If you have any questions on any of these that we've talked about so far, please reach out and let me know. If you want me to go through any of these in more detail, I'm happy to do that over Zoom with you or in my office. 8 through 12, these all deal with improper integrals, right? Where either one of my bounds is infinity. I think that's the case for all of these, actually. One of your bounds is infinity. So just to kind of remind you how these work, let me walk through number 9. So in number 9, I've got the definite integral from 2 to infinity of 2x to the negative 2 dx. I'm really just going to treat this like a normal function. I'm not going to worry about the fact that one of my bounds is infinity. I'm just going to treat this like a normal definite integral by finding the antiderivative and then evaluating it at those bounds. Right? We okay with that antiderivative? I add 1 to the exponent, that makes my exponent -1, and then I divide by that new exponent. Well, 2 divided by -1 is just -2. Okay? So let me just kind of... So this is technically what I did. But 2 divided by -1 is -2. Well, when I evaluate that from -1, or from 2 to -infinity, I get... Remember that that negative exponent moves the x to the denominator, and I get -2 over infinity minus a -2 over, and that's because -2x to the -1 is just equal to -2 over x. X to the -1 just means you move it to the denominator, and you have x to the power of 1, and x to the power of 1 is just x. And sure enough, and remind me, one of the biggest ideas from 5.3 is if you end up with an infinity in the denominator, right? Here I have infinity in the denominator. What does that mean about this fraction as a whole? It goes to 0. So that fraction goes to 0, and I have minus a -2 over 2. That just leaves me with +1. Watch out, because one of these is not going to converge. One of them is going to diverge. See if you can figure out which one is going to diverge. Okay? I'll give you anything that doesn't go to 0 and instead goes to infinity is going to diverge. So see if you can figure out which one will diverge. Number 12, if you look at number 12, 12 is where we talk about a continuous income stream again, but this time it's perpetual. So my income stream, I think it labels it as P for some reason, even though up to this point we've been talking about it in terms of R. If my continuous income stream is $3,400, I'm investing that every single year. My interest rate is 7%. How do I find my present value? Remember, you can't find future value because you're doing this indefinitely. How do I find my present value? Well, if this is perpetually, all you have to do is your income stream. B for present value. Your income stream over the interest rate. And that'll give you your present value. Moving on. Take a look at 13. Okay. 13 is my probability density function example. Okay. So this is going through finding your expected value and finding your standard deviation. So I wanted to make sure and run through one of these so you can see how these ones work. Okay, so I have my interval. My interval is from -5 over 2 to +5 over 2. So this is the interval that my probability density function is defined. And my function is 12 over 125 x squared. There's my probability density function. Well, let's take a look at my expected value. Expected value, if you remember, is just your mean. How do I calculate it? Well, I'm going to calculate this integral over its entire domain, -5 over 2 to +5 over 2 of x times my probability density function, x times f of x. Let me simplify that. I get -5 over 2 to +5 over 2 of 12 over 125 x cubed. Right? X times x squared just gives me x cubed. That makes it a really nice antiderivative to find. My antiderivative here is 12 over 125 times 1/4 x to the 4th. The 12 and the 4 can simplify. They can cross simplify, and I'm going to be left with a 3 up there. Okay. And... but of course, I still have my bounds from -5 halves to +5 halves. I'm left with 3 over 125 times x to the 4th, evaluated from -5 halves to +5 halves. Well, take a look at what happens when I plug these in. When I plug in +5 halves, and then do the same thing but plug in negative 5 halves, because those bounds are the same, just one's negative and one's positive, what am I going to get when I do 5 halves to the fourth? Well, what am I going to get when I do negative 5 halves to the fourth? I'm going to get the same thing. They both end up equaling, let's see, 5 to the fourth is, I believe, 625. They both end up equaling 625 over 16. Both are positive because I'm using an even exponent. And so take a look at this term and this term. They're the exact same. They're the exact same. And so if I subtract them, what am I left with? I'm left with 0. So my expected value for this problem is just 0. Makes sense, because this probability density function, if you think about it, is completely symmetric. It's perfectly symmetric because it's just an x squared function that has not been shifted left or right. So my expected value is 0. Okay, well now let's find the standard deviation. Okay, if you look at the formula for standard deviation, it requires you to know the variance. And if you look at the formula for the variance, it's got this e of x squared thing. Please remember that e of x squared is just the same thing as your expected value, but instead of doing an x times your function, you're doing an x squared times your function. So what does this give me? When I actually, that's just e of x squared, and then I'm going to have minus the mean squared. Well, what's the mean squared? The mean was just 0, and 0 squared is just 0. So that's nice. I really don't have to worry about that second part. So let's just focus on this integral then. I'm going to be left with 12 over 125 of x to the fourth dx. Once again, I'm just left with the power function. That makes my antiderivative fairly simple. My antiderivative is 12 over 625 x to the fifth, from negative 5 over 2 to 5 over 2. And I'm left with 15 over 8 after a lot of simplifying. After a lot of simplifying, I'm left with 15 over 8 because, after a lot of simplifying, minus, and if I plug in negative 5 over 2, I get the exact same thing, but because it's an odd exponent, the negative stays. So I get negative 15 over 8. Well, since I'm subtracting a negative, I end up adding these two values, and I'm left with 30 over 8, or 15 over 4. So that is my variance. Okay? That's my variance. So my standard deviation is just the square root of my variance, which is the square root of 15 over 4, which is square root of 15 over 2. That was just a quick, just to run through that again, because I feel like that video, because it was running so long, I only was able to go through one example of this. So there's another good example of how to work through those expected values and standard deviation type problems. Okay. As we move on, 14 through 17 are all about interpreting the normal distribution table. That's what these ones are about. Okay. So this is all about the normal distribution. 17 is about your percentiles, and I went through that one pretty thoroughly in the 5.5 video. In fact, the problem number 17 is gonna look very similar to that example that I went through, as well as one of the homework problems that was on 5.5. Okay, so let me just kind of run through the basic idea with these probabilities, with these standard distribution. This is your normal distribution problems. So let me just run through the big idea with these normal distribution problems. Okay. If I'm looking at a problem like this is my number 14. These are both z-scores. So I'm going to look up both of these values on my z-score table. I know one of them's negative, but remember, for these negative ones, you just look up the positive one. Okay. Once you have both of those values, right? I'm gonna get the area of 0.4901 for this z-score, and for this z-score, I get the area of 0.4162. Once you get both of those values, well, all you have to decide is, okay, am I going to add these two together or am I going to subtract them? And for this problem, because one of them's negative and one of them's positive, what am I going to do? I'm going to add these together. I'm going to do 0.4901 plus 0.4163. If you're not sure why I did that, or if you're not sure why we add here, draw yourself a picture. And it makes a little bit more sense. If I were to draw a picture of this, there's my normal distribution curve. Remember, this middle is your median. And that's what your areas are all relative to. Here's your negative 2.33. That 0.4901 represents this area. Here's your 1.38 z-score. That 0.4162 represents this area. And notice it wants the probability that it's between those two. So what do? I add them together. Number 16, they don't give you the z-scores, right? Number 16 will give you something like this. What's the probability that's between 28 and 33? What do you have to do? You have to find the z-scores. And so that's where that z-score formula comes in handy, where you do x minus whatever your average is, your number minus your average. Well, yeah, so when I say x, I'm talking about these values. You do your number minus your average divided by your standard deviation. And that'll give you the z-score. Once you have those z-scores, find your areas, and then just decide whether to add them or subtract them. Number 15, I skipped over this one, but just because this one might trip you up. What about something like this? Z is greater than 2.28. Once again, that's a z-score. Look it up on your table. And then all you have to do from there is decide, okay, is that my answer? Or do I need to subtract it from 50%? If you're not sure, draw yourself a picture. Okay. Last, we've got differential equations. Okay. How do we solve differential equations? You'll notice there's a couple of them, 19 and 20, both don't actually require separation of variables. There's no separation of variables that are actually necessary because the right-hand side is completely in terms of x. So those ones are fairly simple because all you need to do is just take the antiderivative, and I think in number 20 you have an initial value, so you would need to solve for that initial value. 21 and 22, you need to use separation by parts. So if I look at 21, dy over dx equals 5x over y. Let's review my steps. First, I want to write this as a differential, which really just means move the dx over to the other side. So step number 1 is I now have it as dy equals 5x over y dx. Step number 2, separate your variables. Get all the y values to the left side. Get all your x values to the right side. How am I going to do that? Just multiply both sides by y. And I'm left with y dy equals 5x dx. Once you've separated your variables, you're ready to integrate. So I'm going to do the integral of y dy equals the integral of 5x dx. These are both very nice, simple integrals that I can handle. Okay, I get 1/2 y squared equals 5/2 x squared. Where do I put the c? Remember, you don't have to put the c on both sides. I always put the c on my x side. This is where, step number 4, this is where if you had an initial value, you would go ahead and plug in both your x and y value in order to solve for c. With these, please be aware, with these problems, you will always be given both the x and the y value. It's not like you'll only be given the x and you'll have to solve for what that y value is. You'll always be given both. in number 21, you don't actually have one, so I'm just going to move on. So number 5, solve for y. So I'm going to multiply everything by 2. I get y squared equals 5x squared. If I had solved for my constant, when I multiply both sides by 2, I would also need to multiply that constant by 2. I would need to make sure and do those changes to my constant value as well. Otherwise, I won't get the right answer when I'm done. But because I didn't have an initial value and this plus c just can represent any constant, I don't have to worry about performing these operations to my constant value as well. So I can just leave it as a plus c. What's my last step? I'm going to square root everything. I'm going to square root everything. So I get y is equal to the square root of 5x squared plus c. Now, this does get a little bit tricky. Okay? This does get a little bit tricky because I think you'll notice on the homework question it says something like, use a comma to separate your answers. Wait a second, does that mean there's multiple answers here? Well, in this case, there actually is. And the reason why is because whenever you square root as part of solving for something, okay, there's a difference between this and the actual square root function. Well, notice this isn't because our function was a square root. This is because we had to square root as part of solving for y. Whenever you square root as a part of solving for something, you have to take into account that your answer, your result, can be both positive or negative. So this answer here will still work even if it's the negative square root of 5x squared plus c. And so that actually gives you 2 different solutions. Positive square root of 5x squared plus c and negative square root of 5x squared plus c. I will let you guys try out all the other problems on this review, but please reach out if you have any questions on, or any specific questions or need clarifications on any of these problems. Have a great day and good luck on the exam.